Okay, so welcome to today's lesson where we are in the topic under atoms, molecules, and what we call as ions. Okay, so under this topic, it's a broad topic. We just want to pick a part of it, and then we can discuss it. Okay, so in this session specifically, we are going to tackle these few things that I've outlined here. The first one, we are going to learn about the subatomic particles, okay? So those protons, the electrons, the neutrons, okay? And then from there, we can look at isotopes and the average masses, okay? And the last goal there is to convert the number of atoms or the number of atoms that you are given, you convert them to a mass, okay? Or vice versa, you are given a mass and then you are told to convert to the number of atoms or the number of molecules. Okay, so let's go straight into it. Okay, so here down here, I just have questions. So I'll be explaining these concepts on the board here. So according to the modern view of an atom, okay, we say that an atom consists of protons and electrons in the nucleus, and then it has electrons in the what? The energy levels. Okay, so if you picture this, so we're going to say modern view of the atom. Okay, modern view of the atom. So we are saying that this atom, okay, consists of the nucleus. So in this nucleus, you are going to find positive particles, okay? And these positive particles here, they are what we call as the protons, okay? So in this nucleus, you're going to find the protons, and you're also going to find the neutrons that are indicated by the letter N there. Neutrons, neutrons like that, okay? And then around this nucleus here, you have what we call as energy levels like that, okay? Energy levels like that. And then in these energy levels, we find what we call as the electrons, okay? We find what we call as the electrons. So these electrons here have a negative charge like that, okay? And then the protons have a positive charge, and these neutrons here have a zero charge, okay? So if I can put it here, I would say the protons, I can hear some background noise. Who has their mic and mute? Let me mute everyone. Okay, so if you have any question, just mute yourself and then you can ask as I explain. Okay, so we are saying the protons here have a what? A positive charge. So +1 charge. And then the electrons have a -1 charge. And then the neutrons, okay, they have what? No charge. They have no charge at all. Their charge is 0. Okay, so this is the modern view of the periodic table, that it is made up of a nucleus that contains protons, okay, and neutrons, and then it is surrounded by energy levels where we find the what? The electrons. Okay, so another thing to know about this is that every neutral atom, okay, I think I should write. So every neutral atom, when you are told that the atom is neutral, it means it contains, okay, equal numbers of, okay, equal numbers of the protons and the neutrons. The electrons, not the neutrons, sorry. Yeah, so if they say an atom is neutral, then it contains the same number of protons and the same number of what? Electrons, okay? Okay, so these protons here, they are very important because they determine the identity of an element, okay? So one element can only have a certain number of what? Protons, okay? So if, for example, you say, let me show you a periodic table here. So if I go on this periodic table here, and then I have an element that I'm calling as oxygen, okay? If that element is oxygen, it will always have what? 8 protons, okay? But the number of electrons and the number of neutrons can differ, okay? But the number of protons is constant, and it tells you the identity of the element, okay? So when just here an element has 8 protons, just know that that element is oxygen, okay? If it has 6 protons, that element is carbon, no matter the number of electrons or the number of neutrons that we have, okay? So the proton determines the what? The identity. And then this electron here determines the chemical properties that that element is going to have, okay, or that atom is going to have. Meaning these electrons here are responsible for the chemical bonding that will occur between the atoms, okay? It is these electrons here that are responsible. Okay, and then the neutrons here, in a neutral atom, they do not have really any type of function, okay? But they come in when we'll be talking about the isotopes, okay? You will see that the same atom can have different number of neutrons, okay? And if it has different number of neutrons, then it will lead to the concept where we say that those two atoms that we have, okay, they are isotopes. Okay, so if I could go back here, I was saying the electrons here, they determine the chemical properties of what? An atom. So meaning for this atom here to react, okay, or to combine with other atoms, it requires either the sharing of these electrons, okay, or the movement of these electrons, okay? So these electrons can either be shared or they can be transferred from one atom to the what? To the other. And that will make or cause a chemical bond to happen. Okay, but these protons here, they are ever constant. So we can therefore say that if the electrons change, okay, if the electrons change in an atom, then we form what? Ions, okay? And then if the neutrons change in an atom, we form what we call as isotopes. Okay, so take note of that. Isotopes, it means you're dealing with what? The neutrons. If you're forming an ion, it means you are dealing with what? The electron. Okay, so the electron can move from one atom, it moves to the other. Okay, so take note of that. Okay, so the representation of these atoms on the periodic table, it will be in the following way. Okay, the representation of these atoms on the periodic table. I know you all know what the periodic table is, right? Okay, so it's just a table of elements. So the representation of all these atoms is in this form. So you have here a big X that will represent the symbol of that atom, okay? And then on top here, you have what we call as, okay, let me look at this periodic table. Where is it? So atomic number is on top. Okay, so I'll go with that. So on top here, you have the atomic number. And then down here, you have what we call as the mass what? Number. So this is the representation of all the atoms on the periodic table. This X here, we said it will be the symbol for that atom. Okay. And then this one here is what we call as the mass number. And then a number that will be on top there is what we call as the atomic what? Number. So the atomic number is simply the number of what? Protons. Number of protons in that element or in that atom. Okay. So atomic number is the number of what? Atoms. And then this mass number here is the number of protons plus the neutrons. Okay, so those are particles that are found in that nucleus there where we had positive charges and neutral charges like that, okay? When you add the number of neutrons plus the number of protons, you're going to get what we call as the what? The mass number. Okay, so a question can be given to you, okay? Where you are given the atom, maybe you are given the mass number, okay? And then you are asked to find the number of neutrons, okay? So you're given these two, and then you're asked to find the number of neutrons. So what are you going to do in that case? You're just going to say that, okay? So there's a formula to say that the mass number is actually equals to, okay, the atomic number plus, okay, the number of what? Neutrons. So if you are given any two of these, it means you can find the third one. So you can be given this and that to find the mass number, or you can be given this and this to find the neutron number, or you can be given the neutron number and the mass number to find the what? The atomic number. So you can be given any. So this formula here is the most important formula that you have to know. Okay, so you will see when we start solving the questions. Okay, so if, for example, a certain atom, let's say atom P, okay, has 18 electrons. Okay, so if this atom P has 18 electrons, okay, and it gains, okay, it gains more electrons. Okay, it means this P, okay, it will have a charge of positive N. Okay, so let's say here it gains N electrons. So this can be 1 electron, 2, 3, and like that. Okay, so if this guy here, actually it has to be a minus. If that guy gains electrons, okay, it means the neutrality in that atom ceases to exist. Okay, so remember we said in a neutral atom we have same number of electrons and same number of what? Protons. So if I have 18 electrons, it means I have what? 18 protons in a neutral atom. So these will cancel out and the overall charge will be what? Will be 0. But immediately this atom here gains n electrons, okay? Gains n electrons. It means you have more negative charges than the positive charges, okay? So it means the overall charge on that atom there becomes a negative, okay? So if it gains n electrons, it means the charge there will be minus what? N. And then if this P has this same 18 electrons and 18 protons, and then it loses, okay? If this P here loses n electrons, okay? So if it loses the electrons, it means you have fewer electrons remaining in that atom, but a lot of what? Protons. So it means the charge now on this atom will just be positive, what? N. Okay, I hope we are understanding, okay? So these are the two scenarios. One, when you are gaining electrons, and then the other one when you're what? Losing electrons. So remember this when we start doing an example, okay? So here I'm just explaining the concept. And then we can now talk about the isotopes. Okay, so isotopes. So what are these isotopes? Anyone who knows to give us a definition? What do you think isotopes are? Hello? What do you think isotopes are?
Isotopes are elements of the same mass number different.
I couldn't get you. I couldn't get you. Can you try to speak up? You are saying isotopes are what?
Element of the same mass number but different neutrons.
Okay, so you're saying same mass number, but different neutrons. Okay, so the last part is correct, but the first one is not correct. Okay,
Yes,
because,
yes.
yeah, so the mass number is never the same in the isotope. Actually, it is what differs due to the difference in what? Neutrons. Okay, so isotopes are atoms of the same element. Okay, so if I say atoms of the same element, I mean that those atoms all have the same atomic number, or they have the same number of what? Protons. And then those atoms have different number of what? Neutrons. So if the neutron number is different, it means even the mass number will be what? Different. Okay, so these isotopes, we're saying they are atoms of the same, okay, atoms of the same element. Okay, so same element here means that they have what? Same proton numbers, okay, or same atomic numbers. Same, I'll say atomic, okay, atomic numbers. Okay, but they have different number of what? Neutrons. Different number of neutrons. Okay, so because they have different number of neutrons, it means even their mass number, I'll just write Mn, even their mass number there will be what? Will be different. Different. Okay, so atoms of the same elements that have the same proton number, but different number of neutrons, okay? And due to that, they are going to have different mass numbers. Okay, so those are isotopes. So the common questions on the isotopes are just where they're asking you to calculate the average atomic mass, okay? So they will give you two atoms, and then they will ask you to calculate the average what? Atomic mass. So those are the common questions there. Or they can give you the abundances of those isotopes, okay? Or actually they can give you the average, and then they ask you to calculate the what? The percentages. Okay, so the formula that we are going to be using will be as follows to calculate the average. Okay. Okay, so if we are given maybe 3 isotopes, let me say isotopes A, then I have isotope B, then I have isotope C, okay? And then I'm told to find the average atomic mass. Okay, so average atomic mass. So what am I going to do? Okay, in order for me to find the average atomic mass, okay? I'm going to get the mass of this guy here multiplied by the percentage of this, and then I'm going to say plus the mass of this multiplied by its percentage plus the mass of this multiplied by its percentage. Okay. Okay, so let's say, for example, let me change these values here. Let me say I have isotopes 1, A1, then I have A2, and then I have A3. Okay, so let this A3 here indicate the mass of that atom A, okay, because it's the same atom. Okay, so we have 3 duplicates of itself. And then let the percentage here be P1, and then here the percentage be P2, and then here the percentage, let it be P3. So for us to find the average atomic mass of these isotopes here, we are going to say A1, which is the mass of this multiplied by the percentage, which is the P1, then plus A2 multiplied by the P2, and then plus the A3 multiplied by the what? The P3. So these here are the 3 what? Are the 3 isotopes for this atom A that we have. Okay, so to find the average atomic mass, we simply use this formula here. Okay, so that is the formula that we are going to use to solve the question that we are going to be solving in a few minutes. Okay, and then what else did I say we are going to do? I said we are going to know how to convert, okay? If you are given a number of atoms, so I will say number of atoms, or you are given number of molecules, okay? And then you want to change this number of molecules, you want to change them to what? To mass. Or it can be the opposite. You can be given this mass, and then you're asked to change to the number of atoms or the number of what? Molecules there. So there are 2 approaches to answering such a question, okay? So the first approach there that you can use is what we call as, okay, just a minute. Okay, so I was saying, how do you convert number of atoms or molecules to mass, or mass to number of atoms and molecules? I said we have 2 approaches, okay? So the first approach is what we call as the more, okay? more approach. Okay, so under this more approach, you have to know the following conversion factor. You have to know that one more of anything, okay, of any particle, and that particle can be atoms, it can be molecules, it can be ions, or it can be electrons. So one more of anything, you have to know that it contains 6.23 multiplied by 10 to the power 23 particles. Okay, so particles can be atoms, can be molecules, they can be ions, they can be electrons. So depending on what you are dealing with, okay, just know that one more of anything, okay, contains this number of particles. So you can use this formula here to convert atoms and molecules to mass, or mass to atoms and molecules, or you can use the simple method, okay, which is known as the atomic, okay, atomic mass unit approach. Okay, so atomic mass unit approach. Okay, so how does this work? Okay, so under the atomic mass approach, okay, you have to know that one atomic mass, okay, so one atomic mass represented by U, or in some books they write AMU, okay, so one atomic mass has the following mass. It has the mass of 1.661 multiplied by 10, okay, to the power minus 24 what? Grams. Okay, so you have to know this relationship here. One unit mass of an atom has this mass, okay? And then the second relationship that you have to know is that okay, so the second relationship that you have to know is that the total, let me say it, how can I say it? Okay, let me find a better way. Okay, so I was saying the first one here is this one, where we are saying one atomic mass unit is equals to 1.661 multiplied by 10 to the power minus 4 grams, okay? And then the other one that you have to know under the atomic mass approach, okay, is that one atom, okay, or, okay, let me just write it like this. So one atom is equals to, okay, so one atom of an element has, okay, or is equal to the atomic mass of that element. So atomic mass of that element, of that element. Okay, so what do we mean by this? So it means that if I have one atom of, let's say, hydrogen, okay? If I have one atom of hydrogen like that, okay, it will have a mass that is equal to the atomic mass of this element. And we know that the atomic mass for hydrogen is just 1 point something, right? So like 1.00, is it 0.8? Okay, so units like that, or you can say atomic mass units. So the first one atomic mass of this is equals to this mass, okay? And then one atom, if I have one atom, it means it has the mass that is equal to its atomic mass, okay? And how do you, where do you find this atomic mass? You find it on the periodic table, okay? Or if you have molecules, you say one molecule, if you are in terms of molecules, okay? So one molecule is equals to, okay, the molecular mass of that molecule. Okay, so if I have one molecule of water, okay, it means this is just going to be equals to 18 U, or AMU. Okay, so these are the relationships that you have to take note of. Okay, so we are going to be using all these things that I've explained to solve the questions. Okay, the question that we are starting to solve now. So I hope we've gotten some concept from here. So we are going now to apply whatever we are learning here. We're going to apply it in the actual questions now. So let's go to the actual questions. Okay, for today. Okay, so let's start with the subatomic particles. Okay, so remember what I explained. So we have this table here. Okay, we have that table there. And then the question is fill in the blank spaces. Okay, so here you have the symbol of that element. You have the number of protons, number of neutrons, number of electrons, the mass number, the atomic number, and if there's any net charge. Okay, so where you should start always is to look at the number of protons there. Okay, the number of protons. So if they say the number of protons is 35, okay, what element is that? Remember I said the number of protons determine the identity of the atom. So if the number of protons is 35, then what element is that? Okay, so I don't have to stress, you're always given a periodic table. So you go on the periodic table, okay, you go and check which one has 35 protons, okay? So these numbers here on top here, they are the proton numbers, okay, or the atomic numbers. These 5, 6. So the one that has 35 is what? You can see there is what? Bromine, okay? So it's bromine there, okay? So we have identified that element. Where's the question? We have identified this element here based on the number of protons that it has, okay, that it is what? Bromine. Okay, so this is bromine, but I'm not going to write it here first, okay? First, I determine the charge here that it has, and then I'll write the symbol for this with the charge, okay? So what are the number of neutrons here? The number of neutrons are 44. So we can use number of neutrons plus the number of protons to find the what? The mass number. Remember, this mass number is just the total of the protons plus the neutrons. Okay, so what is 44 plus 35? Okay, so you can be confirming with your calculator. So if I do 35 plus 44, I'm getting a 79. So my mass number there is just what? 79. Okay, and then let's look at the number of protons and the number of neutrons to see if there's any lost and gain of the what? The protons. So remember we said in a neutral atom, the number of protons should always equal the number of what? Electrons. And we said the number of electrons is the one that changes, okay? So if there are any changes, you're going to notice it on the number of electrons. So if I come here, I see that I have 35 what? Protons. So it means in the neutral atom of this bromine, I also have to have what? 35 electrons. But what do we notice here? Okay, we notice that we have 36 electrons. So it means this guy here, the bromine, gained one what? Electron. Okay, so because originally it's supposed to have 35, but it gained an extra electron to have what? 36. Okay, so if it gained an extra electron, we know that the net charge there will be what? Will be -1. Okay, because it gained. So you can say the net charge there will be 1 minus. Okay, and then since it has 1 minus there, it means the symbol here, the way you are going to write it. Okay, so bromine here is written as Br. Okay, so because it has this charge here, we are going to say the symbol there is going to be Br, a minus charge like that. So this will be the symbol there. Okay, and then we are remaining with the atomic number. So the atomic number we said is always equal to the what? The proton number. So there's no need to stress finding the atomic number. So just get the number of protons and then you can put them there. Okay, so we filled in the first column there. Okay, so if you have any question, please feel free to ask. Okay, let's go to the second one here. Okay, so we notice that we do not have the number of protons here. So meaning we can't know the identity or the name or the symbol for this element or for this atom until we find the number of protons here. That's when we can know. Okay, but what do we have to help us find the number of protons? Okay, so when you look at this column for proton, here it's empty, but the number of electrons here is showing 54. Okay, and then you look at the charge. So the charge is saying -2, okay, or 2 minus. So what does that mean? It means this number of electrons here, they are originally supposed to be what? 52, but they gained extra 2 electrons, and so the negative charge there of -2. Okay, so it means how many protons do you have? We said the proton numbers don't change. Okay, so if this was the original number of electrons, it means the original number of protons is what? 52. Okay, so it gained 2 more electrons. No wonder the charge is what? Minus there. So we have now the number of protons here. Let's get the mass number. So mass number, protons plus neutrons. So we are adding in 52 plus 76. So I'm getting 128. So confirm with your calculator as my mass number. Atomic number, same as the proton number. So this will be 52. Okay, so what is this element here now? The one that has 52 protons. Okay, so you go on your periodic table. 52 is somewhere here. Okay, you can see, that's where I can see 52 there. So 52 is what we call as tellurium. Okay, it's a tellurium. So tellurium has this symbol Te, and it gained extra 2 minus electron. So how are we going to write that? You're going to say Te, okay, and then 2 minus like that. So this is the symbol that we are going to write in that column. So we come here, we say since that's 52 protons, this is tellurium, and then it has 2 minus as the charge. Okay, so we are done here. So any questions here on how we are finding the answers? Any questions there? Okay, no questions. Okay, let's do the one for the isotope. Let's do the one for the isotope. Okay, so here you're saying an element consists of the following atomic masses and the natural percentage abundances. So you can see the atomic masses there, and then we have the natural percentage abundance here. Okay, so you can see that this mass has this percent, this mass has this percent, this mass has this percent. So we know that the total percentage here should always be 100. So we notice that the last one here does not have any percent here. So it is our responsibility to find this percent. So how can we find this percent? We're just going to say this plus this plus this, okay, plus the percentage that should be here. They should give us 100, okay? So it means the percentage that should be there, we can name it X is equals to 100 minus the addition of all these three here. So 1.4 plus 24 plus 1 plus 22.1. Okay, so let's find the percent for that. So if I go on my calculator, please be confirming. I add 1.4 plus 24.1 plus we have 22.1. Okay, so if I add that, I get a certain value, and then that certain value I subtract it from 100, I'm getting a 52.4. Okay, so we have a 52.4% there. Okay, so this is what we have there. Okay, so how are we going to find now, calculate the average what? Atomic mass for this element. Okay, so remember that formula where I was saying you just multiply the mass multiplied by the percent plus the mass multiplied by the percent plus the mass multiplied by the percent plus the mass multiplied by the percent. That's how we are going to find the average atomic mass. Okay, so let's go to the cupboard here and then solve this. Okay, so if we come here and then we say average atomic mass of those isotopes, this is how we are going to find it. Okay, so we're going to say average atomic mass is equals to, okay. So the first mass that we had there had a 1.4%. So we're going to say 203.9730 multiplied by 1.4. Okay, we know that percentages are always over what? 100. So this is the first mass, and then we are saying plus. We put the second mass here. We had a 205.9745 multiplied by the percent, which was 24.1 divided by 100. Okay, and then from there I also say plus. The third one was 206.97. Then I have 59. Okay, multiplied by the percent here was 22.1 divided by 100. Okay, and then I say plus the last one. So the last one is 207.9766 multiplied by the percentage that we found was 52.4. 52.4 divided by 100. Okay, so the only thing remaining is to punch all these values into your calculator. Okay, so let's punch all these values into the calculator and see what we are going to get. Okay. Where is this? Okay, where is this thing? Okay, just a minute. I'm trying to set up my calculator. Okay, so when I punch this one here into the calculator, it's giving me a 2.856 plus. When I punch this one into the calculator, it's giving me a 49.639, and then plus. If I punch this one here into the calculator, it's giving me a 109.188. Okay, and then I punch in the last one, which is this. It's giving me a okay. So this one here is for the last one, and then for the third one, it is 45.639. Okay, and then add all these on your calculator. You get the average atomic mass to be 207.425 atomic mass units. Okay, so this is the answer that I get there when I punch whatever I had on my calculator. So this is the average atomic mass, the ATM. Okay, so any questions on how to find the average atomic mass? Any questions there? Okay, you're too quiet, guys. I don't know if what I'm explaining is really sinking into your heads. Okay, so that's how you can handle a question on average atomic masses. Just know the formula of the percentage abundances, okay, and then you can calculate them. So you can see here we have here we are given the atomic masses. Okay, so they are saying for boron 10 it is that, for boron 11 it is this. Okay, and then the atomic mass of naturally occurring boron. Okay, so this mass, if it's naturally occurring, okay, we're saying it is our average atomic what mass. So here you have the average atomic mass, the mass for one isotope and the mass of the other isotope. And then here we are calculating the percentages. Okay, so use the same concept. Okay, use the same concept. And then let me try to solve number 10 here, where we are converting from number of atoms to the mass, or to the mass, the number of atoms, or to the number of molecules. Same thing. Okay, so let's look at number 10 here. They're saying calculate the mass of nickel, okay, that contains 2.6 multiplied by 10 to the power 19 atoms of nickel, okay? And then they are specifying the method that you should use here. They're saying use the atomic mass unit what? Approach, okay? So we are calculating, we are changing this number of atoms here, we are changing them what? To mass. And I gave the relationships that you need for you to change this. Okay, so let's look at that. Okay, let's change. Okay, so let's come to the board here. So we know, okay, we have been given the mass of nickel as, I mean, the number of atoms of nickel as 2.6 multiplied by 10 to the power 19 atoms. Okay, so we want to change this number of atoms into mass. And that mass, okay, most of the times it is in grams. Okay, so what are we going to do in order for us to change this number of atoms here to the grams? Okay, so it means first we have to change these atoms to atomic mass units. Okay, so remember the relationships that we had. We said one atomic mass unit. Okay, so one atomic mass unit is equals to, we said, what number was that? Okay, that's gone. It was 1.66, okay, multiplied by 10 to the power minus 24. That's what we said. So one atomic mass unit was equivalent to 1.661 multiplied by 10 to the power minus 24 what? Grams. So this was the first relationship that we established. And then the next one was that, okay, one atom, if I have one atom, this one atom here is equals to, okay, the atomic mass number of that very atom, okay? So we said atomic mass of that atom. Okay, so we know that these atomic mass units are in AMU. Okay, so here we've been given the number of atoms. So it means we are going to start with the second relationship there. Okay, we want to change this number of atoms. We want to change them to what? Atomic mass unit. And then once we have them in atomic mass unit, okay, it means we can now use this relationship here to convert them to the what? To the grams. Okay, so let's do that. So we know that here we are dealing with what? Nickel. Okay, so in chemistry, you're always given a periodic table. So we are dealing with nickel here. So we know that one atom of nickel, okay, one atom of nickel, which is Ni, like that, is equals to, so what is the atomic mass unit of this nickel? So you go on your periodic table and then you check for the atomic mass what? Unit. So if I go on my periodic table here and then I look for nickel, where is the nickel? So the nickel, you can see it is this guy here. Okay, that is the nickel there. Okay, so this is the nickel here. So what is the atomic mass? The atomic mass number for this nickel here, you can see that it is 58.6934. Okay, 58.6934. So it means one atom of nickel has this atomic what? Mass number. So we are going to write that relationship there. We're going to say 58 points, forgotten the other numbers, 58.6934. Okay, so 6934 atomic mass unit. So this is for the nickel. Okay, and then what were we given as the number of atoms? You have been given 2.6 multiplied by 10 to the power 19. Okay, so let's use that. So now we are going to say, what about 2.6 multiplied by 10 to the power 19? How many atomic mass units am I going to have here? So you form this ratio and then you simply cross multiply. Okay, so x multiplied by 1, you're just going to get x, which will be equals to this number multiplied by that number. So 2.6 multiplied by 58.6934 and then multiplied by 10 to the power 19. Okay, so you take your calculator and punch those values. Okay, so I advise you first to do the 2.6 multiplied by this 58 there. Okay, so we're going to say 2.6 multiplied by 58.6934. Okay, so if I multiply that, I'm getting 152.60284 multiplied by 10 to the power what? 19. Okay, so these are what now? So these are atomic mass units. So these are atomic mass units. So for this number of atoms here of nickel, you are going to have this as your atomic what? Mass unit. Okay, so now that we have the atomic mass unit, we can use this relationship here. So we know that one atomic mass unit has this mass here. So what about those number of atomic units? What mass are they going to have? Okay, so you say one atomic mass unit is actually equals to 1.661 multiplied by 10, okay, multiplied by 10 to the power minus 24 grams. Okay, what about the number that I have now, which is 152.60284 multiplied by 10 to the power 19 atomic mass units? These are going to be equals to how many grams? So you cross multiply there. Okay, so this multiplied by 1 is just going to give me what? X will be equals to, and then this number multiplied by that number. So I have 1.661 multiplied by 152.60284, and then I'm multiplying by 10 to the power 19, and then multiplied by 10 to the power minus 24. Okay, so the answer you get here will be grams. Okay, so let's simplify this. So what is this number multiplied by this number? Okay. Okay, so the 152.60284, okay, I'm multiplying that by 1.661, okay, and then I'll get this number to 53.47, and then here I have 10 to the power 19, and then I have 10 to the power minus 24. So we see that these are the same bases here. So we can write one base, okay, and then since we are multiplying, it means we have to add these powers here. So what is minus 24 plus 9? Okay, so it's the same as 24 minus 19, and I'm going to get minus 5 grams. Okay, and then you take this number to scientific notation. Remember, scientific notation, the number must be greater than 1, okay, but less than what? 10. So we are moving this decimal place from here, moving it 1, 2. So this will be 2.2. 5347 multiplied by 10 to the power. How many points have I moved? I've moved 2 times and I'm moving to the left. So meaning my positive power, this power should be positive, and then multiplied by 10 to the power minus 5, and then I have grams. Okay, and then from here we see that we are just going to have 2.5. If I round off this, be 3 multiplied by, these are the same bases, okay, but with different powers. So I'm going to write one base, then I'm going to add these powers because we are multiplying. So 2 plus minus 5 will just be minus 3 grams. Okay, so this here, ladies and gentlemen, is the mass of nickel that has those number of atoms. We had 2.6 multiplied by 10 to the power 19. Okay, so these atoms of nickel here will have this mass here. Okay, any questions there? Okay. Okay, it's clear. Okay, so those are the few concepts that I wanted us to tackle today. Okay, so if I don't have any question, I'll end these questions here. But this document here, it has a lot of questions. So I'll send it in a group for your practice. And then I'll see. So I'll make a video where I'll be solving tutorial sheet 1 and 2 questions. Okay. So once I'm done making the video, I'll upload it on the drive. Okay, so you go to the specific folder, you'll find the video for the solutions for the tutorial sheets. Okay, so that you can be going through. All right, so have a blessed night. Thank you so much.